Hello, students, and welcome to the SCA Computer Science Snowed In podcast, videocast, screencast, first one in 2014, possibly the last. We'll see. So I wanted to go over somewhat quickly the PowerPoint for this class. This will be in the Dropbox folder as usual for you to go through at your leisure and talk about what your assignments will be for the week to come. So the goals for today is to be able to use for and while loops effectively to avoid infinite loops at least most of the time, and to be able to decide between for and while loops. So a for loop has a pretty simple structure. It's got the keyword for, of course. This is a label for every item in this list. Okay, so whatever goes here should be a list, and it could be an actual list, like, you give a list of numbers or Boolean statements or letters or something. So this could be it could be strings like A, B, C, whatever. It could be that. Range is a list of numbers, and let's say a big number, for example, is 100. Then range 100 represents the numbers 0, 1, 2, ... all the way up to 99. And it is a list of those numbers. And the way this works is that a number, the variable, the variable I named a number, gets assigned first 0 and then 1 and then 2 all the way up to 99. And in this particular loop, I just print them. So the output of this will look something like 0, 1, 2, 3, all the way up to 99. Okay, so this will just print out each number individually. Sometimes you won't actually use this variable, so you have to do this format for something in and then a list, but you don't actually have to use the something. In this case, we're printing them, but it could just be that you want to do something 100 times or 10 times or 5 times, like you want to draw a 4-sided shape or a 5-sided shape or whatever. Okay. While loops are a little bit different because they're not based on the idea that you want to do something a certain number of times, but you want to do something as long as something is true. So a simple example would be eating until I'm full. And so some condition could be, it could represent true would be I'm not full yet, and false could be, all right, I'm full. So some condition could represent still hungry or something like that. And so while I'm still hungry is true, for example, print it's still true, and then do something that changes that condition, so that changes whether or not I'm hungry. So for example, eat a sandwich. And then I ask again, is that condition still true? Am I still hungry? Yep, still hungry. Okay, eat another sandwich. Is it still true that I'm hungry? Yep. Okay, print is still true. Eat another sandwich. Is it still true? Nope. Okay, done. That's the idea here, and it could be something like an example in the reading you'll see is have a turtle run around as long as it's inside the box, as long as it's on the screen, and they give you a way to test whether or not it's on the screen. But the point is, the condition is the turtle on the screen? And as long as the turtle's on the screen, you're going to do certain things, make it move, make it turn, things like that. So the key with a while is you need to make sure that the condition that you're using changes somehow in the loop. Otherwise, for example, let's say I asked, am I hungry? Print, yep, still hungry, and then didn't do anything about it. So let's say you didn't have this part. Well, you're going to print it's still true, and it's still going to be true, so you're going to print it's still true. It's still true. It's still true. It's still true a billion, billion, billion times, and you're never going to, it's never going to be done. So you got to make sure that something changes the condition and that eventually at some point the condition will be false. Otherwise you've got an infinite loop. So be careful about that, especially if you're doing like saying making sure that a number is less than 100 or something. Well, if it's never going to be greater than or equal to 100, it's always going to be less than 100 and it's always going to be true, and the while loop is never going to end. So make sure if you're using a number or whatever that its value changes. So you can turn any for loop into a while loop. For example, for I in range 10, print, oh dear, that's supposed to be a PowerPoint trying to be clever and uppercase the I, but it's supposed to be lowercase I. For I in range 10, remember range 10 is the number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I will have the values of 0, 1, 2, 3, 4, and then up to 9 each time it goes through this loop. And it's going to print I times I. So in other words, it's going to print 0 times 0, 1 times 1, 2 times 2, 3 times 3, 4 times 4, all the way up to 9 times 9. And that's what it's going to print every time. You can also do the same thing with a while loop. Not necessarily useful, but you could convert this into a while loop and say, well, I is less than 10, print I times I, and then you have to do something else that you didn't have to do in the for loop, which is to make I 1 bigger. Notice that that just happens because range 10 has the numbers 0, 1, 2, 3, 4, so I gets bigger each time. In a while loop, it doesn't automatically change, and so again, you have to explicitly change the thing that you're testing. So you're saying, is I less than 10? If I never changes, you're in trouble. You've got an infinite loop, so you have to make sure that I equals I plus 1. And just as a reminder, let's say you're halfway through and I has a value of 5. Python interprets this code as saying, okay, this side is 5 plus 1, or 6. Great. And a single equals is not a comparison. It's not saying, does this equal? Because of course, I never equals I plus 1. It's saying, assign this, dear, I said 5 plus 6. I meant 5 plus 1. Well, anyway. So 5 plus 1 is 6. And that gets assigned to I. So now I has the value of 6. The equals, single equals is an assignment. So this is basically what's happening in this for loop. It's just shorter. So if you're going to do something 10 times, you should do it this way. Not this way, but you could. So when is for most useful? It's useful when you are doing a specific task a specific number of times. And the task could change slightly each time, and there's ways to do that, particularly using this value, this I value. You could change what happens each time. For example, the first one is 0, and then 1, and then 2, and so you actually use that. But you know you're going to do it a certain amount of times. You're going to do it 10 times, 12 times, 100 times, 1,000 times, whatever. If you know you're going to do something a certain number of times, then a for loop's very useful. If you have something that you don't know how many times you're going to do it, but you can think of a way to make a condition that tells you when you should stop, then that's a good way to do it. So maybe this would, a sort of example would be, for a for loop would be, I'm going to do 100 jumping jacks, and a while loop could be, I'm going to do push-ups until exhaustion. All right, till I can't possibly do any more, whether that's 3 or 12 or 100. The point of the while is that you don't know exactly when it's going to end. You just, hopefully it is going to end at some point. You need to design it so it will end. So, a certain number of times, when you know the number that you want to happen, and when this is just until a condition is reached. Okay, so here is a list of applications, and what I want you to do with this is to take a couple of these and to write out some code or even just sort of pseudocode that's not exactly correct, but to give an idea of what you would do in this situation using what's ever appropriate, either a for loop or a while loop. And so I'll go ahead and give you an example. I'll switch. I want to talk a little bit about project 2 because it's going to be coming up in a few weeks, and I'd like you to go ahead and start thinking about it, and that will be part of your assignment this week. It's got to have all these things. You've got to define your own functions. It's got to use selections, if, else, elif, that sort of thing, for loops or while loops or both. It's got to have user input. It needs to have some sort of output, either text, just printed on the screen, or it could be something that turtles do or something you do with GIFs. Which you'll read about in this chapter. It should have good programming practices, so use comments when appropriate. If you're doing something that's not obvious at all what's going on, particularly if you have a complicated comparison or something like that, definitely put some comments for yourself. You have to have the triple quoted strings in all your user-defined functions. If you use a window for a turtle, please close it on click. Don't use ridiculous number of lines when a simple 4-line loop would suffice, that sort of thing. You've got to use at least 2 imported modules, so random, turtle, math, and there's lots more that you can just import. But those are the 3 that you might think about using. So here's some examples of projects. Say you need a 12-character password with upper and lowercase, boom, generate it. Or maybe you need to use special characters as well, that sort of thing. Flashcards, so you put a term and then you wait for the user to hit enter or something, and then you display the definition. This would be a great way to do this would be with a dictionary and that sort of thing. Unit converter, so for example, I have a certain number of feet, I want to turn it into miles. I have a temperature in Fahrenheit, I want to turn it into Celsius. At least 5 different conversions that could work, and allowing the user to choose. A list of bookmarks, like in your browser, so you have your top 10 favorite sites that you go visit, and this should list them. Allow the user to, for example, choose one, and it'll actually go to it. So you can use the web browser module that's built into Python to actually open a link, and you're welcome to use Google to figure out how to do that. Using a new module we haven't worked with, so it would be Python, Tkinter, however you say that, Pillow, etc. Or maybe you want to come up with your own project that would fulfill all of these things. So your assignment for this week is to read through the chapter, answer the questions as usual, send in by Thursday. By Thursday, we'll say at 4 o'clock, the standard time for our class on Tuesday. So Thursday by 4 o'clock, I want you to send in 2 examples from slide 7, the previous slide that had the one I worked through with this one, okay, the elevator. 2 examples. Does not have to be working Python code by Thursday at 4 p.m. And write a 1 to 2 paragraph project proposal for project 2 due next week by the beginning of class. I want you to have emailed that to me before class starts next week, and it should include all of these things: basic description of what your program will do, who would use it, why, some useful features that you're going to have. For example, you can add new flashcards, things like that. You can edit them. Description of the input and the output. The user will input this and this and this, and this will be the output. That sort of thing. And which part you expect to be the hardest. So maybe it's going to be really hard to, if we do the flashcards, maybe it'll be very hard to allow the user to add new flashcards, add new definitions and terms. Maybe you think that's the hardest. Don't say writing the code is going to be the hardest. And that's it. And hope you enjoy your slightly different day off. Stay warm, and I will hopefully see you all next week.